Welcome to the first of several videos that are going to explain how to use this FIS Multi-Asset Template. I have the template opened up here, and you see it's version 120. That's the latest version at the time of this video. And the blocks are actually contained within a hardware configuration. It makes it convenient if we want to do compiling and things like that to check the integrity of it. So here's all the blocks that make up the FIS template. These 6 function blocks here, 1501 to 1506, are the 6 different asset types. We have a conveyor, vertical lift conveyor, final tool, body tool, process 35, and process 90. Each of these 6 assets makes a call to this common driver here. This driver monitors the live asset data that we program, and when it detects a change, it copies it to the write buffer. These assets also use this RTO, or retentive timer, for calculating cycle times. Here's a multi-send block. This is where you configure all your assets that are going to get sent up. You can have up to 10 assets in any one message, so you can fit up to 10 assets in this block. And this is the block here that actually has the message instruction, FC5. FC5 is the AG send. It's a Siemens standard number is FC5 for it. And that's contained in function block 1611, which is the message instruction. FC 1500 FIS Manager is what calls all of the FIS logic. You need to include a call to FC 1500 in OB1 or an alternative master program call function, or MCP function. This bit search function generates a fault code. It looks at a block of fault bits, manual interventions, or machine faults, a consecutive group of bits, and it turns it into a fault code to be sent up to FIS. This function here is the multi-buffer driver. It manages the data between the write buffers and the message buffer. And we have a data block 1450 here is included as an example data block for your machine fault bits and your manual intervention fault bits. You can program them in here for the assets and reference your blocks of fault bits when you're programming your individual assets. These 6 data blocks here are just the instance data blocks for your assets. This data block here is the instance data block for your message setup function block. And here's your UDTs, or your memory maps, for each of your 6 assets. Let's take a quick look here at the conveyor one. This is a conveyor UDT, or memory map. It defines the structure of data that we're going to send up to FIS. As you see, there's 100 QAS stations in here. And this UDT here is a common UDT. It's used in all of the assets for internal data. And here's the system functions, standard Siemens system functions that we use in our template. That's a brief description of all the blocks. I'm going to kind of walk through the program. OB1 needs to make a call to FC 1500. That's what kicks off all the FIS logic. You could put this FC1500 call in an alternative MCP file if you want, or OB1 is traditionally where it would go. And FC1500, it calls each of the 6 assets in this case. Here's your 6 assets, your 6 asset function blocks, and your message function block. Now this function block here is for message number 1, which can send your first 10 assets. If you needed to send more than 10 assets, then you would have, another function block, 1602, for example, to send your second set of 10 assets. But in this case, we only have 6. Now FC1500 called each of our assets, and we'll just open up one of these assets for an example. First thing I want to point out here is those UDTs I referenced earlier. Here's the conveyor UDT. We just call it asset. So everywhere you see asset dot something, that's writing to the live data. That's what we refer to as the live data, and here's our write buffer. So here's where all the programming goes. Detailed programming examples will come in a future video, so I'm just going to quickly browse through this. You see there's always on. This gets set for the first asset of the PLC only. So if this is happens to be the first asset in this PLC, you put the always on bit here. If this is not the first asset of this PLC, you just block it out if it's like the second asset or third asset in this PLC. This is your data source ID. This is a unique asset ID that will be provided in the configuration spreadsheets. Each asset has to have a unique identifier ID. So that's what goes in here. And this is what I touched on a little bit, the fault bits. Here is your machine fault bits. See this pointer is pointing to DB1450, starting at bit 0.0 for 48 bits. It's going to start looking through this array of 48 bits, and if it finds the third bit on, it's going to turn that into a number 3. And that's going to generate your machine fault code. In a similar fashion, this is also pointing at DB1450, but starting at byte 6, bit 0 for 32 bits. And once we determine what bit is on, the first bit that's on, we're going to add an offset of 48 to it. This will help us generate a unique fault code that's different than the machine fault code. As you go through this template logic, you'll see these edit.bits. Indicates that this has to be replaced. This one here is the cycle start. So this edit.bit has to be replaced with some code that indicates, for example, that this is the start of the cycle. This is going to be unique to every particular asset or piece of equipment, but everywhere you see these edit.bits in the template, that means there's some logic programming required here. And there's instructions you see above every network or require programming right here that describe how to program this rung. This says cycle start. This gets set at the beginning of the machine cycle. So whatever set of conditions indicate the start of this machine cycle, it would go here. Good cycle, another edit bit, so on and so forth. You go through this asset, programming it according to these instructions, and you see at the end here, we make a call to the driver. This driver basically monitors this live data that we're programming, which we call asset, for change, and copies it to the write buffer. After you program all your assets in your PLC, you need to configure the message that's going to send up the data to your collector. And that's what is in here. This is asset 1. So here's station 1, the conveyor. Here's your write buffer. And here's your queue status. Note that the data starts at byte 0. We're sending up one message, remember, for up to 10 assets. This particular message is only going to contain 6 assets, but you can put 10. The second asset's data is going to start at byte 400, or dent 100. We offset each asset by 100 dents, or 400 bytes. So the first asset goes at byte 0, second asset byte 400, third asset byte 800, so on and so forth. After we get through all 6 assets, we call the message. Inside this function block contains the AG send. We don't have to edit this function block. All you really have to tell it is connection ID. This connection ID is what's defined in the hardware network configuration, and contains the information on how to connect to the data collectors. And that wraps up the brief introduction to the FIS template. In upcoming videos, I will be explaining how to use this template to create specific configurations for PLCs depending on that local PLC's FIS asset requirements.